My name is Abdul Karim, and today I'm gonna be explaining some MATLAB fundamentals in order to help us in our numerical analysis course. Uh, First of all, let us explain the MATLAB environment. As we can see here, this is our editor window, and this is our command window. In our editor window, we're gonna use our whole code in order to print out some specific outputs that we want. And here in the command window, it's just like fast operations. If we wanted to do some fast operations, then we're gonna use the command window for it. First of all, we're gonna start by assigning the scalars or the single values. Um, First of all, we're gonna have to know that MATLAB is an extension of C language, so whatever rules that are used in C language, they are used also in the MATLAB language. First of all, we're gonna see how can we assign the variables or the single values. As we can see here, we have five variables. We can do, of course, normal numbers like 5, 10, and we can also do some 3.14 as a decimal number. We can do also negative numbers. Um, Also for the variable that is used, we can do like two character variables. So in this case, we use here E3. This stage only contains the assignment stage. So if we do some running here for only these lines, we can see here that it assigned the values for us. So here is 5, B is 10, and C is 3.14, D is -7, and for A3 it's 3. At any time we can check the variables. For example, I'm gonna try A3, and gonna enter. As we can see here that A3 is assigned as 3. Here we use the check from the command window. Using capitalization in MATLAB is sensitive. So if we use uh, a small letter like E and we use another letter, and it's the same letter but the in uppercase, it's gonna have different values. For example, it's gonna be uh, a different value. As we can see here, uh, E is 15, while the small e is 20. We're gonna move next to the predefined variables. Um, One of the most important predefined variables, not only in MATLAB, in the whole world, is pi. Uh, I assign p as pi and capital P as pi plus 1. So whenever I'm running this, it's gonna be p is equal to pi and p capital is equal to pi. In order to get the exact value, I'm just gonna have to write p and enter. This is 3.1416. And for capital P, it's 4.1416. In order to have longer format, we can just use format long. Then use P, and we have having a long format of this number. Uh, there's a whole list for formats, long, short. It's all right here. You can check it whenever you want. Our next topic is complex numbers. In complex numbers, we can use I and we can use J. So if I run this code, it's gonna be just like this. It's Z1, it's equal to 2 plus 3I, and Z2, 4 minus 2J. It's just like how I typed it. And of course, it's stored right here as Z1 and Z2. We're gonna move next to character strings. So this is where we store characters as variables. For example, here we have like C1, it's I stored it as Barcelona, and C2 I stored it as Real Madrid. So whenever I just uh, run this code, it's gonna be C1 assigned as Barcelona and C2 as Real Madrid. So if example, uh, if I wanted to make a sentence out of these characters, I can just write sentence and put the equal and put our brackets, and I used C1 as Barcelona. So for example, I'm gonna use C1 and use comma because it's a sentence, so I have to separate the variables. And then I'm gonna complete my sentence. I'm gonna put these quotations, not because it's a character. So let's say is better than, and I'm gonna continue the sentence by assigning by using the C2 as Real Madrid. So by running this, I'm gonna have my sentence as Barcelona is better than, and of course by using the space it would be much better. So here we have our whole sentence. Our next topic is arrays. First of all, an array is a collection of single values. And as an array, we have one-dimensional array and we have two-dimensional. For one-dimensional arrays, it's going to be called a vector, and for two-dimensional arrays, it's going to be called matrix. So first of all, we're going to start by the vectors. Uh, Here we have a row vector. So if we assign this, we're gonna have a vector that is expressed in row. So 1, 2, 3, 4, 5, all in one row. And if and we have also the column vector. We're gonna see how to write it later by running this. We're gonna have 1, 2, 3, 4, 5, but it's in a column, in one column, and 5 rows. And final thing is matrix. By using this, we're gonna have 3 rows and 3 columns, and we're gonna see how to write one now. So for writing a row vector, all we have to do is do the assigning of a variable. So I wrote here rv1 as my first row vector, and we're gonna use our equal, and we're gonna use these brackets uh, to separate these values, so we can have multiple rows, multiple columns. In row vector case, we can use spaces like this, and we can also use commas. So by running this code, we can see here that's exactly the same result. It's also right here, RV1 and RV2. It's the same result. However, a column vector can be written in multiple. We can write it here as it's shown here as semicolons, and we can also write it as a row vector, then do a transpose at the end, which makes it mean that this is a column vector, not a row vector. And also we can do the same thing, but with the commas. We can also use write it by using insert. So if I use 1, 2, 3, 4, this is gonna be understood as a column vector. We're gonna see also by running this, it's all the exact same thing. And by the way, the column vector is much more used in Matlab than a row vector. Okay, so we have here how to write a matrix. So I'm gonna assign M1 for our first matrix. It's logical because we have this is our first row, this is our second row, and this is our third row. And it's all separated by semicolons, which makes it this 1, 4, 5, 7 is our first column. 2, 5, 8 is our second column. 3, 6, 9 is our third column. So we're gonna see it in the workspace right now by running this first. It's called M1. So we're gonna go here. As we can see here, 1, 4, 7, 2, 5, 8, 3, 6, 9. 3 by 3 matrix. So if I wanted to Uh, I can also write it in multiple ways. For example, I'm gonna use multiple ways of writing uh, row vector with column vectors. So I'm gonna have m equals those parentheses. Uh, we're gonna have 1, 2, 3, 4. So this is our first column. I'm gonna then use uh, for the second column. I'm gonna write as this 1, 2, 3, 4. And of course, we're gonna use the transpose because this is a column, but I wrote it as a row. Then by using the transpose, it's gonna be a column. So by using this semicolon, it should be assigned as two columns: 1, 2, 3, 4, 1, 2, 3, 4. So it's into 1, 2, 3, 4, 1, 2, 3, 4. In MATLAB, we can call an element row or column by using these expressions. So if I wanted, like, for example, the element at row 2 and column 2 from the first matrix, I'm gonna start by M1. I'm gonna assign first the variable W is equal to M1. Then I'm gonna open parentheses. This is the number of the row that I want, and this is the number of the column that I want. So in this case, I'm gonna go to M1. So this is our second row, and this is our second column. It should be the value. The value should be 5. So if I run this, and here we're gonna have the value of W is 5. So and also here we're gonna see how to call an entire row. For example, I'm gonna need the row, the second row, but I want it in all columns, all of columns. So I'm gonna write by using a colon. This means that we want all of the columns of the second row. So I'm gonna run this, and we're gonna see. First of all, I'm gonna see M1. So it should be 4, 5, 6. We assign the variable x as this row, and we can see here that is 4, 5, 6. Also goes the same thing for an entire column. So here we wanted the second column, but we wanted all the rows of it. So we used the column here. For here M1, it should be 2, 5, 8. By running this, we're gonna have 2, 5, 8. We can also call an entire matrix. So for example, if I wrote Z1 is equal to M1 parenthesis, I'm gonna write two columns because we're gonna need all of the rows and the columns. So by running this, we're gonna have our whole matrix as M1. Then we're gonna move to sequences and how to write them. So for example, first sequence, this one, I'm gonna assign it as this one. This means that I'm gonna start off from 1 and gonna end by 10. But here, the step is not defined. So it's used as 1. So if I run this, we're gonna see S1 as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our default step is 1. But what if we wanted to specify the size of steps? This is our first point, this is our endpoint, and between them we're gonna have the step size. And of course we're gonna spread them by columns. So starting by 0, ending by 10, and our step size is 10. So logically it's gonna be 0, 10, 4, 6, 8, 10. We're gonna run it and see. S2 is 0, 2, 4, 6, 8, 10. We can also have a reverse sequence. So we're gonna start by 10 and end by 0, and our step size is minus 2. So it's gonna start by 10 and then 8, 6, 4, 2, and 0. So S3, 10, 8, 6, 4, 2, 0. So in sequences, the size of step is specified. But what if we wanted to specify the number of steps, not the, and we didn't care about the size of steps? Here we're gonna have the line space. Here, by using the line space, I'm gonna assign it as L1 line space. For example, here I'm gonna start by 1 in this line space. I'm gonna start by 1 and I'm gonna end by 10. But I want 5 steps. I don't care about the size of step, but I want 5. So if I run this, I'm gonna logically have some decimal numbers. So as we can see here, 1, 3.25, 5.5, 7.75, and 10. The second kind of this is log space. So in log space, it's similar to the line space. However, we start by 10 to the power of the first point, which is here is 10 to the power of 0, and we're gonna end up by using 10 to the power of 2, so which is 100. And between them, we're gonna have 5 steps. So by running this, we can see here what is L2. 1, we started by 1 and we ended up by 100. We can also do an example of reverse line space as we did in the sequence. For example, I'm going to assign it as L3 equals to line space parentheses. I'm going to start by 10 and then we're going to go to 2 and we're going to also need 5 steps. So, semicolon. By using this, we can see L3 here decreasing from 10 to 2 in 5 steps. We're going to move then to mathematical operations. We have here our four main mathematical operations: addition, subtraction, multiplication, division, and also I added the exponential. So it's just like a normal calculator. For example, I assigned x as 10 and y as 3. So just by using the normal plus symbol, here we're gonna use the minus, multiplication, division, and exponential. We can also check here by running this code. So, okay, so here I assigned our operations as add variable, sub variable, multivariable, division variable, and exponential variable. So, add variable is nothing but x plus y and subtraction and so on. So, if we run this, we're gonna have x as 10, no, I'm sorry, we're gonna have add as 13, and we're gonna have sub as 7, and so on. In matrix multiplication and division, there's an important point that need to be taken into consideration, which is whenever we use this multiplication, it's gonna do a matrix multiplication that the multiplication that we all know. But if we use this multiplication, so it's just a multiplication symbol uh, after some dot. it's gonna be element wise. So the answer of M4, it's gonna be 1 multiplied by 5, so it's 5. Then 2 multiplied by 6, which is 12. And we're gonna see here by running this, and we're gonna see here by running this. So if we go to M4, this is, as I said, 5, 12, 21, 32. However, in the M3, which is the normal multiplication, if we use the matrix multiplication, we're gonna have this matrix as an answer. Let's do a quick check on division as well. So we're gonna assign M5, and we're gonna use S, and I'm gonna use first of all as normal division or semicolon. And for the sixth matrix, I'm gonna use S using the dot, then division or. So if we run this, we can see also the same thing. So if we do, this is the normal division that we know in matrix division, and this is the element. So whenever we use the element wise division, we're gonna have this result. And our last part of this video, it's rounding operations. So we have here uh, three functions, which is round, floor, and ceil. And we can predict what does every one of this means. So if we're gonna use round, then it's gonna be a normal round. So 3.67, it's gonna be a normal 4. If we're gonna use 4 floor, then it's gonna be a round down. So 3.67, it's gonna be 3. Seal, it's gonna be a round up, so it's gonna be 4. We're gonna do a little run here. So we can see here that R1 is sorry, R1 is 4, R2 is 3, and R3 is 4. And by the way, we can check all the variables if I just write in the comment window by just writing who. It's gonna give me the whole variables. So A add B, C, our whole variables. And if I wanted to know how much size does it take, I'm gonna just write whose. As you can see here, it's shown. It shows the size of it, the bytes, class, and attributes of this variable. If I wanted to clear all the variables, all I have to do is just typing clear. So it's all now cleared, and we can also use the CLC to wipe all the command window. the